Hey folks. Hey folks. Better. Okay. Hey folks, how are you folks doing today? Good? Good? Smiles? Good? People had snacks? You know, always, I know that usually, at least for me, at conferences, this time of the day can be that course out of the sugar and the snacks and the coffee's worn off and you just slightly get to that peak. So hopefully you do enjoy this talk, and I really, really want to start by saying thank you for coming. Without having an audience here in front of me, I wouldn't be able to actually give this talk. So thank you very much for coming. And you may be intrigued by this title. I will say when I actually first wrote this talk, it was just after Fast X had come out, so it was very heavily themed on the Fast X movie. But it was actually a sequel to a talk that was given by a former colleague of mine, someone I still respect very highly to this day. His name is Phil Nash, and he gave a talk called 2FA2Furious a couple years ago, and he spoke about why it's important to use 2FA, and he actually also spoke about some of the algorithms that underpin, for example, one-time passwords, both timed one-time passwords and hash-based one-time passwords, and a few other things. So lots of people know about 2FA, especially as it has kind of taken a bigger part of our lives and the applications that we use. And I'm here to kind of follow up just like the Fast and Furious movies. But allow me to reintroduce myself to those who may have met me. Hello again. To those who have never met me before, hi. My name is Nathaniel Okenwa. My friends call me Chatterbox Coder because I talk a lot and I write code. Love to do that. And another thing that I like to do in my spare time is I train in MMA, so I do jiu-jitsu and Muay Thai. I love anime and superheroes, and I love action movies. So finding any reason to connect action movies to something at work is always something I'm very, very, very excited about, which is why I was inspired to kind of combine this with the Fast and Furious movies. But before I do that, also let me tell you about the people who pay my bills. I am a developer evangelist at a company called Twilio. Just out of curiosity, how many people in this room have heard about Twilio? All right, that's good. When I started this job, not many people, it was always a minority in the room. I saw a few hands were not up, so let me just quickly tell you what it is. Twilio is a telecommunications API, set of APIs that help you with communications. So that could be sending text messages, which we will kind of talk a little bit about in here, sending emails, phone calls, and I can almost guarantee that you've used Twilio in the past week, maybe month or so, because we are used all around the world in different applications. But what we are all here for, Fast and the Furious. The first movie came out in, I think it's 2001, but my mind has blanked just now. And it was all about this police officer, his name is Brian O'Connor, who went underground in the street racing scene to bust a criminal gang. And he actually gets enamored by the street racing world that he actually went in to destroy. Fast forward 10 movies later, we now have Fast X, which is a completely different set of movies. The first one was about street racing. This one's an international spy thriller, and it's all about Dominic Toretto protecting his crew and his family from a new villain who has connections to them in the past, who is seeking revenge from their father's death. Now, the timeline of Fast and Furious is very, very complicated. Just out of curiosity again, how many people here have watched at least one Fast and Furious movie? All right. How many people have watched all of them? Kindred spirits, kindred spirits. How many people have had the pleasure of never watching a Fast and Furious movie? Impressive, impressive. Okay, so it has a very, very convoluted timeline of so many different movies with slightly different plots. But honestly, I can simplify it into 4 things that happen in nearly every movie. So, in every Fast and Furious movie, a villain emerges. It could be a new villain, or sometimes, like they always do, it's an old villain that comes from a character's past. A villain emerges kind of at the start of the movie, and that villain always takes a hostage. It could be a person or a piece of technology. In the last movie, Fast X, it was Dominic Toretto's son. In other ones, they have stolen fictional pieces of technology like God's Eye, which can find a person from anywhere on the earth in space, but they always take something hostage. And then there is a recurring theme in the Fast and Furious movies that the family grows. A new member gets recruited into the team, and over the course of the movies, the team, Dominic Toretto's team, grows and they recruit new members. Many of these members also used to be villains in previous movies, but the family grows, and the movies always end with a massive, big confrontation. The more collateral damage and explosions, the better. We've had planes crashing, being brought down by cars. We've had them going to space. We've had electromagnets ripping up Edinburgh. But there's always a big confrontation. But we always end with happy family saying grace around the table. Now, you didn't come here to actually listen to me find a way to talk about Fast and Furious. You came here to learn about 2FA and how there are some security vulnerabilities. But let's talk about security vulnerabilities because they kind of follow that Fast and Furious pattern. Because every time there's a security incident, this new villain emerges. So a new exploit or a new vulnerability is discovered. And then villains take hostages. So bad actors use these vulnerabilities to gain access to secrets or something that they shouldn't have. And then new best practices, new recruits are added to the team. And then instead of a big confrontation with lots of ridiculousness, we have a race. Fast and Furious, racing, street racing. We have a race where engineers like ourselves in this room are racing against the bad actors to close those security vulnerabilities and holes and prepare for the next ones. There is first trying to catch up to make sure that all the vulnerabilities that are open are closed, and then trying to overtake them and make sure that we are one step ahead of these bad actors. And we end up in happy family of safe and secure users. So remember I said this is a sequel to a previous talk? So let's talk about that talk and give you the previously on 2FA2Furious. The hostage was passwords. How many people have checked this website? I never know how to pronounce it. I'm going to call it pwned. How many people have checked it? All right, cool. A lot of people. That's nice. So for those of you who don't know, this is a website that collects information about different data breaches that have had. And they can actually tell you if your email and a password associated with that email has been leaked on the web. And who can guess how many emails and password combinations have been exposed by Have I Been Pwned? How many have been exposed that we know of at least? Who can guess? Just throw a random number at me. Billion. A billion? 2.5 billion. Say that again? 2.5 billion? 50 billion. Ooh. Well, it's kind of in between. It is 12.9 billion as of this morning. So that's a lot. And I refresh it every time I give this talk because it does go up. And that's 12.9 billion accounts that have had an email usually and a password combination leaked. And as we know, many people, maybe not necessarily people in this room, because lots of us are engineers who maybe are aware of some of these security risks, but many people actually use the same email and password across different platforms. So even though this may show accounts from specific platforms, it also extends to people who've used the same email and password combination on other platforms. All right, so the new recruits came. So we brought in 2FA. We had SMS, which many of you may be familiar with when you get a message saying, here is code to pop into a platform to log in. We also had one-time passwords. We had timed one-time passwords where there will be an exchange of a key at startup, and then based on time, the code will change. And then there were also hash-based ones, which work very, very similarly, but rather than rotating every X number of seconds, they actually rotate after each use. So every time it's used, it rotates. And then you had push notifications, especially when there were a lot more native apps that companies were developing. You could use push notifications to do that. And we used it for a couple of different things. We used it for verification, and we used it to protect logins and make sure users are who they say they are, and then authorize transactions, so extra protection for important actions. So maybe if there was a credit card use that maybe was a bit fishy, you might trigger 2FA just to authorize that transaction. And we were living in a world of safe and secure users, or so we thought, because there is a new threat in the 2FA2Furious world. Now, some of these villains are very familiar. How many people are familiar with SIM swapping? Okay, this is interesting. So SIM swapping involves a bad actor impersonating somebody to their phone network. So if I pretended I was someone else and I phoned their phone provider, maybe it was T-Mobile or 3, and I said, hi, I would like to have a new SIM card sent to my new address. I now have that person's SIM card, I can receive their SMS 2FA messages, and there is a breach that way. It was also vulnerable to phishing. This happened especially with people who were not familiar with how to stay safe on the internet, where they would maybe be phoned by someone who is a scammer, and the scammer says, okay, I'm going to send you a 2FA code, can you read it to me? And then they gain access that way. But there may be one that many people here aren't familiar with, because this one is very, very new. And it's actually quite different to other things that targeted 2FA, because it doesn't actually target you users, it targets you. Specifically, it targets your wallet. And that is SMS pumping. I want to know how many people have heard about SMS pumping, because not many people know about this, and this is why I'm here giving the talk. All right, we have one. Oh, you've... Nice. So it's when fraudsters request one-time passwords from your platform over and over again in order to generate fake SMS traffic. And that SMS traffic they are incentivized to do this by small local carriers. I'm just going to dive deeper into this to explain it. So you have a fraudster, and you have a mobile network operator. So we maybe know many of the big famous ones like 3 in the UK, T-Mobile, EE, Orange, I could go on and on. And usually these big companies that are enterprise and work in very established and regulated markets, they're pretty safe. However, the phone network is kind of an array of different providers across the world. And in many countries where maybe there is a lot more corruption or a lot less regulation, you have some mobile networks doing some dodgy dealings, let's say. And what they can do is they can say to an actor, they can say to someone, if you are able to drive traffic, SMS messages, to a premium number that costs more to send messages to, we will give you some of the profit we make. So now, all of a sudden, a bad actor's like, oh, I'm going to get money if I'm able to send SMSs to a specific phone number. But I don't want to pay to send messages to a specific number. Where on a line can I find lots of people willing to freely send text messages to phone numbers? And many of those are just built into your login flows, into your sign-up flows, where someone's signing up or logging in, and then you can just trigger a message, a one-time password, to a text, to a phone number. And so what they do is they build bots that do many, many verifications to your application. They never actually go and confirm and actually put the code in. They just care about sending the text message. And then what happens is at the end of the month, you get a big bill from the provider of your 2FA. And it's not their fault. They did send the messages you asked them to send. However, they were being sent to maybe premium numbers where they were being charged more by the other network provider on the other side. That's how these people have been making use of that vulnerability. Now, it has affected our lives. How many of you remember when Twitter turned off 2FA for free accounts? It was because of this. Twitter was getting scammed. They're a big company, so they're doing millions of verifications, probably a minute. They were getting scammed for $60 million a year of fake 2FA SMS messages. So it's a big problem, and that's kind of why he turned it off for free users and only turned on 2FA for users who paid. But we also know that that's not necessarily a good thing. Maybe in isolation, turning 2FA off could be an easy solution, but 2FA was there for a reason. It protected these users from other things. Turning it off completely isn't necessarily going to be the best way forward. So we need to figure out how we can spot SMS pumping. And let's talk about how we can spot this fraud, and then we'll talk about how we can mitigate it. So the first thing you should watch out for are conversion rates. So remember what I said, these fraudsters, they do not care about actually completing the verification and popping that code back into the website. Their job is finished the moment your application has sent that one-time password. So monitoring OTP conversion rates and then watching for differences. If all of a sudden you have a lot of messages being sent without those messages being converted on, in terms of those people actually completing their login, something fishy is probably going on. Also, if you suddenly have traffic spikes, and these traffic spikes are maybe country specific, and then maybe also have similar number prefixes, because remember, these people are working with phone network operators. A lot of times their phone numbers will be like 1, 2, 3, 4, and they actually just are in ascending order. And once you notice the pattern, it's easy to spot and block them. And then also, if you have unexpected destinations. So if you're a small company working in Europe, you have no real business outside of Europe, and you suddenly have a massive amount of 2FA messages coming from Australia, something's fishy. 1, maybe, 2, okay, 100,000, not so much. And then last but not least, you can actually maintain a list of carriers and look at suspicious and safe phone networks. So if it's maybe a T-Mobile or an EE, and especially because they actually label whether it's like a business phone number or whether it's a personal phone number, you can usually trust that that's a person. And then there are some other carriers which are a little less trustworthy, and keeping an eye on what those are can help you. All right, so we've spotted the fraud, but we need a hand. We need to recruit a new team member into our pocket so that we can work our way around this. And we actually have a bunch of different ways we can solve this. So one of the ones we can start doing is by introducing rate limits to your 2FA messaging. It's actually mostly good to just be having rate limits on, because the provider of your SMS, whichever platform you use, will probably have rate limits on their own side just to stop DDoS attacks and stuff. So you should also have rate limits to stop yourself from hitting their API limits, and also to stop yourself from having a specific user who triggers too many authentication calls in a very, very short period of time. I'm going to pause and just take a breath. I'm talking really fast. And then you should also employ bot detection. So libraries like captchas, they can help you detect and deter bot traffic as well. So you can notice, okay, this is a user. These are certain things that help us identify that this is a real person. And there are certain things that can help us identify that this is a bot. Obviously, these things are not perfect and should never be used in total isolation, but these are some tools you can use. And then also number lookups. So a lot of the providers that you are probably using to send two-factor authentication messages, they often offer services where you can give it a phone number and it can tell you a bit more information. So it can tell you what the carrier is. It can tell you, for example, if it's a personal number or a business number, if that number is programmable, which is really, really useful, because that can tell you straight away, oh, someone can write code to manipulate this phone number, and that can give you a hint. which is quite nice. And then a lot of companies, I know Twilio does and a few others do, will actually also give you like a ranking. They'll be like, this particular phone number has been used in the past and is a bit fishy, so keep an eye out for it. So these are some of the things you can use to stop these attacks coming in. Now, another thing which you can do, another tool which you can add into your toolkit, is to actually diversify the channels through which you're sending your two-factor authentication messages. So I started by talking a lot about SMS 2FA, but there are other forms of two-factor authentication you might want to use. Specifically, more people are using email for two-factor authentication, and a lot of people are using WhatsApp as well. These are really good in some ways. There are some pros, there are some cons as well. Specifically with email, you can become overly reliant on an email account, and the moment an email is compromised, the person's screwed. It doesn't become a second factor. So keep an eye out on that. And WhatsApp actually, especially in certain countries, in the US, for example, WhatsApp doesn't have a massive amount of adoption. But if you go to South America, you go to Africa, it's oftentimes more easy to reach people on WhatsApp than on SMS. And the great thing is, SMS pumping just doesn't work on WhatsApp because the only person who'd get the revenue share is Facebook. And they don't really have an incentive for that at the moment as well. And they work on Wi-Fi as well, so there's something else in it. So these are really good because they use things you already know about using and not going out of your way to add, to collect more information or to ask them for more setup. You can start using them almost straight away. And remember I said there were new things being added to the team. There's a new thing coming that has been cooking by a bunch of different companies, which is called silent network authentication. And it relies on secure carrier network technology. So essentially every time you take your phone out and you turn it on, there is a handshake, and it's done when your SIM card is made first, and then it's used every time you connect to a phone network that lets a phone carrier and a SIM card identify each other securely. And the great thing is you can actually do this in the background. So to a user, they don't notice that two factors has happened at all. If they're on their phone, they can log into something, and in the background, it's automatically doing a two-factor authentication to go, this is a phone occupied by the user, and it's a phone on this person's network. And it's so secure, they use it to actually bill you for your usage on the phone. So it's very, very reliable. And the great thing is, most other pieces of security have an added layer of friction because you have to do an extra step. And this takes that extra step, but actually keeps that level of security. So if you have a mobile app, this is really, really, really useful, and you should check it out because it's quite good. Now, every time I give this talk and I talk about two-factor authentication, I talk about SMS 2FA especially, I talk about some of the problems with it, like SMS pumping, like the fact that phishing still happens and SIM swap. Everyone says, yeah, well, why don't you just use authenticator apps? And if you don't know what I mean apps like this that use timed one-time passwords or hash-based one-time passwords. They're really good, they're secure, they work offline, you can bring your own app. I think they're one of the highest levels of security as well. And many people here might be familiar with them. Google have their own authenticator. This one is Authy, which is quite popular. And there is another, Microsoft has another very popular authenticator as well. And these are really good. They're actually super effective. So Google did some research. And what they did was they looked at the different challenges and looked at account takeover prevention rates. So with a certain method of two-factor authentication on, how good was the protection? So you can see that when you had on-device prompts, when you had security keys, 100% all the time, especially against automated bots and bulk phishing attacks. Targeted attacks, those are where it gets slippery. Usually that's when someone has dialed down onto one person and is also implementing a bunch of different techniques. So maybe they're doing a bit of social engineering, maybe they actually have access to the person physically and maybe can steal their phone and things. So the targeted attack, as you can see on the on-device prompt, it's like 90%. On the SMS code, you might look at it and go 76%. That is terrible. We should never use SMS to send 2FA at all. And I'm like, yes, it's not ideal. It's not the best in terms of all of the options, but it has something that the others don't have. And if you dig deeper into the research, not what they just published in the nice graphics on the marketing site, but you actually go to the paper where they studied it, and you dig deeper, you notice that they have this abandon rate. And you'll notice that when it was a device prompt or a device settings, which stands for the one-time passwords, 64% of people abandoned it. And that was even when they were familiar, like this was their familiar device. If you can see, it says familiar and unfamiliar. Unfamiliar means it's a new phone. So you're setting things up on a new phone. You're incentivized to finish your login because you won't be able to use your phone without it. So usually those end up having lower abandon rates. But you can see that 64% of people who are using these higher levels of friction just abandon the task. And because of that, we all live in a world where we work for companies that want to make money, and these companies need users to make money often. And users abandoning and not using your service because they find your platform to have too much friction can be bad for you. I saw this Slack message and I had to ask the permission if I could take a screenshot and put it in my talk, where someone says, my personal email provider is way too intense about 2FA. Getting hacked should be a risk I'm allowed to take. And this brings us to a real conundrum. There is user experience and usability on one hand and security on the other. How do we balance both? Because a lot of times the most secure methods have the most friction. And making it too easy makes it easy for the bad actors as well. And one of my favorite gifts, it's a balancing act. We have to figure it out. But I am going to come with a little kind of way to frame approaching this question, this balance between usability and security. And that is using the bank security model. It's not trademark, but maybe the trademark is pending. I'll speak to my lawyers. And what I mean by the bank security model, fun story, I tried so hard to look up the blueprints for a bank online. Obviously, those are very, very hard to find. I had to settle with a blueprint from a video game called Payday. I'm not sure if anyone recognizes it. And in this, you can plan a heist on a bank. And in this blueprint, there are a couple of things I want to highlight. You have where the bank tellers are. Now, this is a part of the bank that is high frequency. Lots of people are coming in, they want to check in a little bit of money, take out a little bit of money, do a couple of frequent transactions. And this is where you have these high frequency but low risk activities. You're still in a bank is still secure, so there are still minimum requirements of security, but here you have not a lot of friction. And then you have the safe. And in your application, this may be some higher risk activities. You want to prioritize a more secure form of authentication. So, for example, many people may be familiar with, and I'll give an example about this later, I'll talk more about it in a second, GitHub, where when you're doing certain things, if you maybe want to change security settings, it will ask you to do another two-factor authentication as well. And so maybe if there's a higher risk activity, you maybe want to just have a little bit of a challenge and maybe pick a higher form of authentication. And then you have what I call the safety deposit boxes. And the reason I say safety deposit boxes is specifically, if you lose your key to a safety deposit box, you're pretty much screwed as well. It's kind of like you hear these Bitcoin stories online of people losing their Bitcoin and people who have maybe pass keys, losing those. It's the highest risk. It requires a lot of user education, but it is also very secure. And what I would encourage people to do is think about your platforms and think about your users on their platforms. Where do your users think they sit? Do your users just want to be interacting with the bank teller? Or do they want the security of the vault? So if you, for example, are just building a small application, it's not maybe small, it could be a big application, that's just gonna track how many coffee points a person has in a year. Do you need to go full two-factor authentication with passkeys and one-time passwords? You might want to, but you also are bringing in a lot of friction for your users. But if you're working in financial services and maybe you're moving above a certain amount of money, you might want to say, okay, when people hit certain criteria, we are going to tell them to use another form of, a more secure form of two-factor authentication. And I think GitHub is a great example of a company that does this really well. They give their users many different choices about different two-factor authentication methods. So you can see that this is from mine. You have the Authenticator app, you have SMS messages, you have security keys, you have the GitHub mobile app, and you also have some recovery codes as well. So I can choose what my risk tolerance is as a user. For some people, they will say, never use SMS and text. SIM-swap is too much of a risk for me to take. I want to only use Authenticator apps. Whereas for some people, they go, I only work on open source projects that don't necessarily break the bank. So I am good with an SMS text message so I can get in quickly. And then companies are able to maybe specify more strict forms of authentication. So I have to either use my Touch ID or get my physical passkey if I want to log into my company's GitHub, for example. So what am I trying to say from this is when you're looking at your applications, kind of do a risk profile and figure out what your users are going to do, what risks, what levels of security you want to give them, and give them those options, give them the power, so that people who are maybe not necessarily educated on some of these more secure forms of authentication, they can still use your application, but then you're still giving them a blanket of security by setting a minimum standard that they must meet for certain interactions. All right, so it's all about finding the right mix to keep your, to build this, but at the same time, you kind of want to keep the requirements low as possible. So what you would probably have is you would have a verification request. It might be on the app, it might be on the website. And usually, especially at scale, you would run a service that just handles two-factor authentication. So any of the different applications, wherever they are, can request, like this user, can you send a two-factor authentication code? And then inside your service that verifies them, you can do a bunch of things. You can maybe go, oh, let's check if they have an app. And if they do have the app, we'll do a silent network authentication in the background. Okay, maybe they don't, but they don't have silent network authentication as an option, but they have the app. We can do a prompt on the app, an app notification. Maybe they don't have that, but they have one-time passwords already enabled. We will use those. Okay, they don't have those, and this is a low-risk event. Let us send them a text message or maybe an email or a phone call or a WhatsApp. So building a service that can look at the different requirements and then figure out what they need is something that you can do. And what you end up with a very, very complicated verification solution that has a bunch of different parts, a bunch of different options for security, and a bunch of different solutions and places where you might roll them out. So I understand that usually at the end of a talk like this, when people ask me, what do I need? I always go, it depends. So I'm just gonna give some recommendations that I think are useful to everyone first, and then I'm going to talk a little bit about ways that you can actually offload this work away from your developers' time as well, so that you can keep yourself secure. And I'm going to talk about two buckets. So let's talk about the front end. So validate phone numbers on sign up. There are people who legitimately get locked out of accounts because they put their phone number in wrong when they signed up, and then now they can never get a correct 2FA verification. This does happen, and this is like just a user experience kind of a bad choice, a bad take. So make sure you're validating phone numbers on sign up. And then if you can, store a preferred multi-factor authentication method. So decide this user, do they want to use WhatsApp? Do they want to use SMS? Do they want to use a one-time password? Just like we saw from GitHub. And then you can signpost available alternatives, alternative multi-factor authentication methods. How many of you have ever been in a situation where you needed to log on to a website and your phone was dead? That has legitimately happened to me. My phone was dead and I couldn't receive a 2FA message on it. I just had to wait until it was charged. One thing I do like is because I have a one-time password application set up and I have it on my desktop as well, on my phone, and it's also on my desktop. So I was able to just say, oh, I can switch which authentication method I want to use, and I can just use my Authy on the desktop. So giving them those choice. And in the front end, you should limit retries. And what I mean by that is you should give the user the opportunity to send a message again if something goes wrong. But at the same time, you should limit that inside your UX. And I actually built a little example to kind of show what that could look like. So if I hit this login button, it's got my email and password, and it says, here is some 2FA authentication. Thank you very much. I appreciate the call out because I wasn't paying attention. There we go. Let's start this again. All right, so this is a random cookie website that I use to just throw demos on because I like cookies. And in this, I might want to log in to my account. And we can see here that I hit login. It actually did send me a 2FA text on WhatsApp. I'll pop that in a second. And we can see here that I could hit retry, but right now, the actual UX is stopping me from retrying. And this can be really, really useful, especially if you use an SMS, because sometimes it just takes a couple of seconds, and what you don't want is to block legitimate users. So giving them very clear indicators of what is happening right there lets them know. Giving them other options. So here, actually, I've got, it can tell the way I've built this application, it knows that my user uses WhatsApp. So it sent it to me over WhatsApp, but then I can say use SMS instead if I wanted to use something else. And so this is the kind of flows. This is a very basic UI, and you'd probably make it look way prettier, but those options, giving the user options and information so that they know what's happening. But at the same time, some basic bots won't be able to get past this page in order to spam your 2FA phone numbers. All right, let's close this and head back here. Cool. So you want to limit retries on the front end. And then on the back end, you need to re-implement retry logic. Now, I understand dry. I understand that you don't really want to. Why are you doing retry logic on the front end and the back end? And there is a very specific reason I say this, because one of them is specifically more about user experience. But a good, I was going to say developer, but a good bad actor would just go and look at what API call is being made when you hit this page. How can I maybe recreate that API call, if that makes sense? And they can work around your UX. And if someone's going to do that, you want something on the back end that can still catch them. So the front end is more to tell the user what's happening. You're not getting another text message, not yet, wait 20 seconds. And then the one in the back end is also there to tell any bad actor who's kind of worked around that UX, like, no, you're not gonna get through. And then also track retry attempts. So keep running counts of how many retries have been made in a short space of time. I will talk a little bit about a way you can do that, and then also building a permanent block list of maybe carriers or specific information. So these are some recommendations that you can take, and I'll just talk about what that back-end architecture might look like. So a lot of people, when they start, they just have a user interaction. So a user is logging in, and it goes straight over into sending a multi-factor authentication method. No, did I delete the slide? No, okay. And that is not what we want. We want... Give me a moment. Sorry, folks. There we go. My deleted slide is back now. We want something that's a little bit more complicated. So we have a user. They do the interaction, and they're able to log in. And then we go to that user's profile, go to the user settings, and we find out what is their preferred mode of multi-factor authentication. Okay, so that's the first thing we can find this in our application. Now, this magnifying glass stands for certain, I would just call them lookup services. So there are services where you can take a phone number and find out more information about it. So you can find out, is it a landline? Some basic things like, is it a landline? Is it a number that is a premium number, so it charges you way more to send messages to it? Is it a number sometimes that has been associated with SMS pumping or fraudulent behavior in the past? And you can take that, and then you can use this information that you've gathered to run against a checklist of maybe filters that you have. So for example, you could say, if it's this carrier, absolutely not. If it's this particular country that we don't serve, don't let this SMS message go out. And then here, you may notice that I've got this database with a little clock, and that is to talk about retries. So what I mean by that is you want to keep a tally of how many times this person has tried something, and then you want that tally to expire after some time. Does that make sense? A way that you can actually implement this really, really easily is, thanks to the EU, lots of databases have time to live built into their databases. So you can make a database of retries, hash the phone number, and just say how many tries there's been, and give it a time to live. And if that number, if it exists when another SMS is made, SMS factor authentication request has been made, you can then just go and update it and say, now there's 2 retries, 3 retries, 4 retries. But then if they don't touch it for X amount of time, because of time to live, it automatically gets deleted and purged from the system anyway. So that could be an easy way to build it out. But what you want is you want to have logic that can just, in a short space of time, track how many attempts from a specific number have been going on. And then only after all of these checks have been met, do you then want to send this message. Now that was very, very complicated. First a tank, then a plane, now we got a spaceship. And a question that Twilio's founder used to always ask is, why isn't that an API? And this is for where, folks, transparently I earn my paycheck. Because there are different companies that have a bunch of solutions, and Twilio is one of them, where they actually just have this all in a box. So Twilio has this thing called Verify, where you just give it a phone number, you say, I want SMS or WhatsApp, and a few other authentication methods, and it goes and handles the two-factor authentication for you. And what's really good about that is we actually have something called the fraud guard of guarantee. This is something where we guarantee that we will stop SMS pumping so much that if it happens, we will pay the bill for you. So now there's not just us, there are a bunch of other providers who also have a similar thing to fraud guard where they will help protect you from SMS pumping. So if you are using a provider already, definitely go and check it out. Because for a lot of providers like Twilio, it is a case of just logging in and switching it on, and then you have peace of mind. But what I want to do in transparency is also tell you what you can do to build it yourself. So you can go and look up that phone number, you can create those retries and keep track of retries, and create your own logic to tell when you're going to send these messages or not. But it's your plan. You've got to embrace it. Like, I can't tell you everything that you should do. You should also take it and work on your applications so that we can have safe and secure users. Now, if you do want to find out more, my colleague, Kelly Robinson, she is a developer evangelist at Twilio. She actually handles all things security. She wrote a talk on, she has a video on YouTube that you can check out if you maybe want to see a demo of this in action as well. I'll leave that on there for a couple more seconds. Cool. And without further ado, thank you for listening. I really appreciate having your time. And I open the floor to any questions. Yes?
Have you told Elon about Twilio Verify?
Oh, we did. We did. Can I say that? Scratch that from the record. I'm sure someone probably told Elon. Okay, I don't know whether Elon was told Twilio Verify exists. But I'm sure that within their cost analysis, there are people who look at the risk rewards. They made that decision that the risk wasn't worth it. And also, when you're working at that capacity, like 0.1% of fraud is a massive number. So maybe he knows, maybe he doesn't. Maybe he also just wanted to knock a little bit more money off the value of the company. I don't know. Yes?
You mentioned a few times about identifying specific carriers of phone numbers and not allow them to be used for 2FA effectively. Is it not possible to sort of configure your account so that you just never send premium text messages?
Yes. The simple answer is yes. But that requires you to be using a service like Twilio. What I was trying to do is trying to make this Twilio agnostic as much as, please come pay my paycheck. I do want just developers to, the fact that I ask what is SMS pumping and no one puts their hands up is a worry. And a lot of times it's really unfortunate because developers, rightfully so, maybe they are angry on Twitter because they feel like they didn't know that this happened and they got left with a big bill. So we do give you the option to turn it off. We don't turn it off just automatically for you because for a lot of people, especially bigger companies, that could be a massive amount of legitimate traffic that gets turned off. And if you're getting billions of SMS messages sent out, and even if it's just 0.1%, that's a lot of angry people if those are false positives. Yes?
In one of the slides, there was the new technologies like FIDO, FIDO2. Is that an evolution of the MFA landscape? That's the next future channel.
Well, I think WebAuthn is just going to change the way we interact with logging in, specifically on our computers. And I call it, I put it in future channels. I know it's here, but it hasn't reached mass adoption because we're using it, for example, in a lot of technical use cases, but not many people are just using it to log on to Facebook, if that makes sense. So in the wider end user landscape, it's still brand new. It's still the future. That's why I've put it there. But I do think it will become a big part of how people authenticate online. I think it will be a really, really powerful factor, another powerful way that we can do two-factor authentication. So the answer is it's coming. It's just, I don't know if it's got mass adoption yet to a point at which I'd be like, you should implement this on your coffee app. Cool. I'm going to do 10 seconds of embracing the awkward silence. Thank you, folks. I really appreciate having you here. And just like the wonderful words of Dominic Toretto, it's all about family. And I like being here with the NDC family. Thank you.